Chapter 2, Question 3, or first questions of the Chapter 2. Determine the concentrations of ethylene oxide that will cause 50% fatality. So let's draw this down first. We are looking for ethylene oxide. That if the exposure occurs for 30 minutes, so meaning if we have T equals 30 minutes, and we look at the probability of 50% fatality. So this one go back to the probability equations where you're going to use table 2.4 and table 2.5 to run this calculation. So have your data formula and data handbooks ready. So let's take a look at this handbook. So I have uploaded this booklet. I call that a handbook because it's really useful. And in time, so you have to download the copy, and the hard copy will be given for your final exam. So get yourself familiarized with the booklet and to see what is inside here, what formulas are given, etc. So you can see from here, we are going to use a probability equations here. Given here, y equals to k1 plus k2 ln v. So, and we are also going to use table 2.4, 2.5 to look for the data that we need. Okay, so let's go all the way down to table 2.4. So this table we are going to use 2.4, 2.5. Okay, so let's go back to the question first. So just now we look at the formulas. It is y equals to k1 plus k2 ln v. So from table 2.4, so y value we can get it from table 2-4 at p equals to 50%. So let's take a look at table 2.4. So here we are. So P, these are the P value. This percentage here is the percentage of be it fatalities or anything that for us to calculate the probit value. So 50%, 5, 0. So this is our Y value. Okay, so the Y value, the probit value here is 5.0. So let's put it back here. This is 5.0. Okay, so now we want to find out what is the K1 value, K2 value, and V values, and these three values can be taken from table 2-5. So let's take a look at table 2-5 here. We are looking for, what was the chemical again? Ethylene oxide. We are looking for ethylene oxide. So go to table 2.5, look for ethylene oxide. Yep, I think we found it here. You can see ethylene oxide depth. Okay, and as we said that this first value here, this is the V value, and we have our K1, K2 value here. So this is the V, which is a summation of C to the power of 1 times T. And K1 is negative 6.19 and K2 is 1.20. In case you're wondering what is C, what is T, you can go all the way down here and you'll find it's written here. C is for concentrations in ppm and T is time interval or time of exposure in terms of minutes. So if we are going to put all this value back into our formulas, so we will have y equals to negative 6.19 plus 1 ln summations of C 1.0 T. So in this case, we have 5.0, okay, negative 6.19 plus ln to the power ln to 30 C, since t is already given at 30 minutes. Okay, so when we rearrange this formula, so you get ln 30C equals to 5.0 plus 6.19, we get 11.19. So when we move this 30C, you will get e to the power of 11.19. So in other words, you get, if you put in your calculator, you will get something like 72,403. Therefore, your concentrations of exposure is 72,403 divided by 30. And in this case, you have 2413 ppm. So what does this mean? Okay, so in this case is where at the concentration of 2413 ppm of ethylene oxide in the air, and if the people get exposed to a duration of 30 minutes, the fatality is expected to be at 50%. So meaning in that case, if let's say we look at this value as an engineer, we want to either reduce this concentration, let me use a different color, we either need to reduce these concentrations or we want to reduce the durations of exposure so that we can reduce the percentage of fatality.